Oops. Okay, this chapter. Oh, why do I keep doing that? There we go. This chapter is about finding the area of different objects. Most of the objects, I think all of the objects that we're going to find the area of, we've discussed in some way or the other, throughout the whole entire, the whole entire book. So there'll be quadrilaterals, there'll be all kinds of quadrilaterals, like parallelograms, there'll be rectangles and squares and triangles and circles and trapezoids and blah, 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 all that good stuff, okay? So what we're going to do is find the area of all these different things, and it's not too hard. I think it's pretty easy stuff. You just have to memorize some formulas, and most of the formulas aren't that hard to remember. A lot of the formulas are going to show you how we came up with the formula, and maybe that'll help you out a little bit. One of the most basic formulas that you've learned is area of a rectangle. So this is a rectangle right here, and oopsie daisy, I don't want that. I want this line tool. Alright, so I'm going to try my best to make little squares out of this thing. I don't know if I can do it exactly, but it'll be close enough. You might have to use your imagination just a little bit. So maybe move that over just a little bit like this, and then, I don't know, that looks about in the middle. I know, I said they may not look like perfect squares, but I don't care. Actually, let's, I don't know, what if I put some more in there? Do you think it might make it better?
That was pretty close.
Oh my gosh.
This will be pretty close.
And I think you put more across.
Yeah, I need to, actually, let's just take this one. Where's it looking like a square like that? Right there? Yeah, I do have a grid on here. I guess I could have used that, but that's alright.
No, this is the fun way. Though.
Oh, this is great fun.
Yeah.
Did you just copy that whole top part?
I could have done a lot of things, but I didn't. This is how I'm doing it.
He has a method to his madness.
Not really. I'm just winging it. Just winging it. There we go. Pretend they're all perfect squares, okay? Use your imagination. So what we're going to do is, if I wanted to, listen please, if I wanted to count up all the squares in here, you learned this a long time ago when you were a little kid, didn't you? You don't have to count every single one of these squares. What can you do? Count across. So how many across? 1, 2, 3, 4, 5, 6, 7, 8 across, right? And 1, 2, 3, 4, 5, 6. Down like this. So there's 6 rows of 8, aren't there? So if you have 6 of something, what is that word? That's multiplication. 6 times 8 is 48. So there's 48 squares in here. So let's pretend that's each one over is 8 inches. Okay, each block is 1 inch. All right. And again, use your imagination. Pretend that they're perfect squares. And let's say this was 6 inches right here. So what do we have? We multiplied 8 times 6, which is 48. But we also multiplied inches times inches, right? What's inches times inches? Inches squared. So it would be inches squared. Or a lot of times they'll say square, and we'll just shorthand it, square inches. Okay? It means the same thing. Inches squared, square inches. So when you talk about area, because we'll get away from this really quick here, and I just want you to be able to come back to this point and say, okay, what are we really finding? Because we're going to be finding the area of some weird looking stuff. And what are we really finding? We're finding how many squares can fit inside of that figure that you're trying to find the area of. Does that make sense? We're trying to find out how many 1 by 1 squares can you fit inside that particular shape. So this one was pretty simple. All right, that's why I always like to start off with this one, because that's pretty easy. 8 by 6, 8 times 6 is 48. And then that's 48 squares, 48 square inches. So let's come up with a little formula for the area of a rectangle. All right. Now, when you're a kid, you probably learned that this was the length, didn't you? And this was the what? The width. All right, or L and W, and that's fine. There's nothing wrong with that. But we're going to change it a little bit. Instead of calling it length and width. If you look at this, I told you at the beginning this was a rectangle. So what kind of angle did this width make with the length? Made a right angle, didn't it? Okay, so instead of calling it length and width, what I'm going to do is I'm going to call it base and height. Is that all right? Because we're going to use that a lot more with the other figures than what we use on this. So I'm going to call like this whole entire bottom right here, I'll call this, let's get rid of that area rectangle word. Scooch that down. Oops. I forgot my little cross thingies. Alright, so watch. This would be the base. And what do you think this is right here? This would be the height. So let's call it that instead of length and width. Is that alright? So we'll call it base and height. So what's another way to write the area of a rectangle? Instead of saying length times width, which what we're kind of used to, yeah, let's just say base times height. Is that alright? So that's what the area of a rectangle is. In fact, it's not just any rectangle. It's actually, oops, I copied and pasted it. Yeah, let me find it. I had copied it, but then I, whoops, okay, copy, and then this. Alright, there, let's go back to this. There we go. Now look, this is a nice, what is this thing? It is quadrilateral, but it's a parallelogram, okay? It's a parallelogram. And so how do I find the area? It's not just of any old rectangle. It's the area of actually a parallelogram. Parallelogram. Here we go. So this formula right here is not just, doesn't just work for a rectangle, it works for any parallelogram. Okay, so the area of a parallelogram is what? The base times the height. I'll just put BH next to each other. Yes? Alex. Yeah, we're getting there. We're getting there. We're getting there. Okay? I got a method. Okay? I know where I'm going. So just bear with me. Watch this. So the area of a parallelogram is the base times the height. So taking a look at this parallelogram. Now, going back to this, remember, the base and the height have to be what to each other? Come on, I just drew it. Perpendicular to each other. That's right. They got to be perpendicular to each other. We've talked about that quite a bit before, haven't we? About base and height being perpendicular. We did that with, what were we studying when we did that? Oh, just like the distance, you know, the length from one point on a line and all that kind of stuff being perpendicular. Okay, so, the base and the height would have to be perpendicular in this situation. But look, if I called this right here the base, would this slanted line right here be considered the height? Why not? Is that right? Is that the word you really want to use? Thank you. I thought after all this time, people would say it right. Not just straight down. We don't say straight down. Matt, please don't. So we're not just saying that it's straight down. What do we say? It's perpendicular. Okay? So it really from any point up here, okay, perpendicular to this base, that right there would be the height. Okay, that's the height. That purple one right there is your height if it's perpendicular to the base. Does it make sense? Okay. So it's taken from this slanted line and it's perpendicular here. Now watch. I could draw all kinds. I could draw from here to here. That would be the height, wouldn't it? Okay. I could draw from here to here if I wanted to. All right, that would be the height. Agreed? If I wanted to, I don't see any reason to do this, but I could extend that side, couldn't I? And then do what? Go from this, as long as it's perpendicular to where that base would be, that would still be considered the height. Agreed? Alright. That's if what? That's if this right here was the base. So if this is the base, all these purple ones right here would be the height of that parallelogram. Let's draw it a little bit differently, though, this time. What if I considered this to be the base? Right here. And a lot of times, people don't think of that being the base. But, let's go the same color just to keep it coordinated. Yeah, you can kind of turn your head a little bit, but what is it? Where would the height be if this was the base?
It would be
Would this,
horizontal, no.
would that be the, no,
it'd be
because that's,
sideways.
so it'd be like that. Would that be it?
Perpendicular to.
That's right. It'd be perpendicular to the base. That's right. Okay. So this would be a base too, wouldn't it? Right? Because it's a parallelogram. So if this is the base as well. So if this was perpendicular, guess what this would be right here? That would be the height, wouldn't it? Make sense? Okay, that's not too hard. So to find the area of this thing, that's the easy part. If they just told you these numbers right here, if they said that this base was 5 and this height was, I don't know, 4, then what would the area of this whole thing right here be? It'd just be 20, it'd be, I wanted to write it out, 5 times 4, base times height, which would be 20. Square whatever they are. Okay, let's say it's centimeters this time, so centimeters squared. You okay with that? All right, so that's all there is to that. Pretty simple stuff. Just have to realize what it means. Okay, let's do a quick example here. Here's an example straight from the book, and they're going to ask you two things. They're going to ask you to find, first of all, the perimeter. We've actually talked about perimeter quite a bit earlier in the year. We talked about finding the perimeter, and they also want you to find the area. Let's do the perimeter first. Okay, so the perimeter is just the distance around this whole entire thing, isn't it? So remember, it's a parallelogram. They tell you in the problem that this is a parallelogram. So if this side is 10, what do you think this side over here is going to be? 10. If this is 4, then this is 4 right there. So really, that's pretty easy. You do have to realize, though, that it is a parallelogram. If they didn't tell you that, you couldn't just assume that this side is equal to this side. Does that make sense? Okay. So what do I got? That's 20 and that's 8, so the perimeter is 28. Now, is the perimeter in inches squared? Let's go centimeters. No, it's just what? Just straight up centimeters, right? 10 plus 10, right? 10 centimeters plus 10 centimeters, 20 centimeters, 8 centimeters, 28 centimeters, right? There's no squared or cubed or anything like that. But area is different. Area is squared. So how do we find the area? Area is the base times the height. So how do I know which one is the base and which one is the height? They have to be what to each other?
Perpendicular.
Perpendicular. So you look for the two that are perpendicular to each other, which are what? 5 and 4? Is that what you said? It's the 10 and the 5. Look. See, this is perpendicular to the 10, right? The 10 goes from here all the way to here. This is perpendicular. So this is the height if you consider that to be the base. Does it make sense? All right, so it's those two right there. So you multiply them together. It's 5 times 10, which of course is 50. If it's centimeters what? Squared. Now in geometry class, I'm not going to be real picky if you don't put the squares and stuff. Some teachers will be. Okay, some teachers would mark it off if you didn't put the units or you didn't put them in correctly. I'm more concerned that you know which one is the base, which one is the height. You multiply the numbers together, okay? But there may come a point, listen to me, there may come a point where you're going to have somebody that's going to mark off if you don't put this in there. So just get used to putting the units in there, all right? It's not that difficult. All right, we good with that? Let's go to something else. All right, let's quit being silly. Let's do this. Actually, let's not do that. Let's do this. Let's do a rectangle again. Let's pay attention, please. Let's not worry about that silliness. Let's pay attention at what we're doing right here. Watch this. What if I took this and I drew a diagonal from one corner to the other? I started off with a rectangle. I told you that it's a rectangle, okay? And it was. It's a rectangle. So I connected, went from one corner down to another corner, drew a diagonal right here. What do you think's true about these two triangles that are formed? They're congruent to each other, and we've discussed that before. That's been something that we've talked about before. Now, there's a postulate in this book that says if two figures are congruent, which these two are, correct, then they have the same area. It's almost like common sense. It's like, why even make a postulate out of that? I mean, if they're exactly the same triangle, they have exactly the same area, right? Would you agree? Yeah. So, but it is a postulate. They tell it to us, so we know that they're both the same. Now, remember, this was the base, and this was the height. So what's the area of the whole entire rectangle? It's base times height. But what about this one triangle? Just
Half base times height.
that's right. And so the area of a triangle, I'll put AT for there, for triangle. The area of a triangle is just 1/2 the base times the height. Or you could write it base times height divided by 2. It's the same exact thing. That's how they get the formula for the area of a triangle. It's really not that complicated, is it? They just basically took a rectangle. You could do that with any parallelogram, but I just took a rectangle, split it in half. I got two triangles, so this is half of the original rectangle. Original rectangle is base times height. I took half of it. That's the area for any triangle at all. All right. There's basically three different situations here. Oops. Oh, what did I do there? Okay. Yes, it is. Me second. Let's take a look at this. I have a right triangle right here. Now that's the easiest to find the area of for the most part, because most of the time they would put this as the base. Which one would be the height? The one that's what? Perpendicular. Well, no, not. I don't want to say it's the one that's not the hypotenuse. I want to say it's the one that's what? Ben, you said it. You just said it. It's perpendicular, right? The one is perpendicular. Okay, so the two that are perpendicular to each other, the base and the height. Does it really matter that I called this the base? Could I have called this one the height?
Yeah.
Yeah, absolutely. But I would have to call this one the base. It doesn't really matter which word we give to it, okay? So what's the area of this triangle? It's just 1/2 the base times the height. And I can put some numbers in. I think you can do that on your own, can't you? All right, here's another situation, though. So this was a what? A right triangle. That was easy because you already automatically have two sides that are perpendicular to each other. But what if you had a triangle that you didn't have two sides perpendicular to each other, for instance, like this? I'm going to make it like that. So what kind of triangle does that look like? As far as the angles are concerned. As far as the angles are concerned. Angles.
Scalene.
Scalene and isosceles deal with the sides. Listen to me. Okay? It's an acute triangle because I'm talking about the angles. Alright, I said that a couple times. The angles, they're all acute angles, so it's an acute triangle. So, if I call this side right here the base, now I could have picked any of these three sides, but I just happen to call this one the base. I got to find out where is the where is the height? Is this one the height right here? No. Is this one? That looks a little more. No, because it's still not perpendicular to the base. So what do I have to do? I got to go from the top of my triangle where? Not straight down, but say, Rachel, perpendicular, okay, to the base. So that yellow one right there would be the height. Sometimes, listen, sometimes you have to come up with the height and figure out what it is. Sometimes they'll just tell it to you. All right. Here's something a lot of people get confused about. I'm not really sure why, but a lot of people think once they put the height down to here, they think just from here to here is the base. But it's not. It's the whole. It's still the whole entire bottom of that triangle. You see that? That whole thing's still the base, even though we dropped the height down to here. I don't know. I see a lot of people make mistakes and think that way. But it's the whole thing is still the base. We good? All right. Now look, if I wanted to, I could draw the height from the other vertices, like from here. Where would the height be? Would it be there? Would it be up there? It would be about right in there somewhere.
Oh, this is
Okay.
like the thing we did before. It's called the.
So if this, yeah, but right, it's true, but that would be the height, wouldn't it? Okay, so that would be the height. What would be the base? That would be the base to this height. You got it? All right, and you could do the other way too, right? You could go from here, perpendicular, and it does. It goes through that point. I even forget what the name of that, what the word is. It's one of the circumcenter or something like that. I forget exactly what it is. But anyway, there we go. All right, let's do another one. We did a right triangle. We did an acute triangle. What do you think is next?
Scalene.
How about
Obtuse.
obtuse? Thank you. Okay, look. So what if you had like this? Oops. All right, here we go. You watching? Here's an obtuse triangle. Again, let's just call this the base for lack of better terms, I guess. I don't know. No, just, I mean, I don't know. It's sitting on this. A lot of times they call it the base. Okay, I could have called this the base if I wanted to, right? And I could have called this one the base, but I figured I'll call this one the base. Now, which one's the height? Is this side? Is this length? This height? Is this length the height? No. Is exactly right. I have to extend the base. Do you hear that? So what I'm going to do is I'm going to do this in a different color instead of extending it out. Watch. I'm going to take this, extend it out a little further. Just a little bit. All right, so I extended this side out a little bit. So where is the, what's the height of this thing then? Okay, let's do It goes from the top of the triangle where? Perpendicular to the base. Now, I know it's not really hitting the actual base itself of the triangle. It's hitting where the base would be if we extended it out. Does that make sense? Okay, so that if that's a right angle right there, then this orange looking one is the height. Now, where's the base? Does the base go all the way to here?
No.
No, it's not. The extension part isn't part of our base. Our base only is from here to here. And again, that's another thing that for some reason people mix up. Okay, it doesn't go all the way to here. This is not, all this stuff right here really isn't part of the triangle, is it? Okay, it's just a little extra. It's just an extension of the triangle. But this is the actual part of the triangle right here. So that's your base, that's your height. How do you find the area? Multiply them together, take half of it. Pretty easy, isn't it? All right, let's do an example. And I think we'll be done after this example. It says the height of the triangle is 5 centimeters more than its base. Did you hear that? The height is 5 more than the base. So, I mean, it doesn't say which one is the base. It really doesn't matter. Let's just call this one the base right here. And it says the height is 5 more than the base. Well, let's draw the height in there. So let's draw the height. It would go from here and it would go perpendicular to the base. Agreed? Now, it says the height is 5 more than the base. So do I just like say, okay, well, the base is 2 and the height is 7. Is that what I want to do? No, I put the base plus 5, right? Because it says the height is 5 more than the base. So if I called the base b, then the height has got to be b plus 5. Make sense? Okay. Joanna, you getting all this? Okay. Oh, I know she can, but she still needs to get her head up. All right, so let's take a look. We want to find the area of this triangle right here. How do you find the area? It's the base times the height, what? Divided by 2. All right. So what is the base of this triangle right here?
B.
It's b. Times the height, what's the height? B plus 5. And it's over 2. Oh, by the way, almost forgot. They tell you what the area is. Yep. They tell you the area, I think it's 52. Let me look. Yep. They tell you the area is 52, so we stick a 52 in for area. All right, so we got to find what the base and the height is. So let's write it a little bit nicer. So it's b times b plus 5 over 2. Now watch, the math is a little bit more complicated than what you're used to, but it's something you'll definitely have to do in Algebra 2, so let's pay attention. First thing to do, I would get rid of the 2. How do you get rid of the 2? Times it by 2, times that by 2, so that's what, 104? What do we do with this b outside this parentheses? Distribute it, right. b squared plus 5b. Yes, we do. So, or you could factor if you want to factor.
Yeah, they tell us to factor it.
Do they tell you to factor?
I forget how to factor.
All right, I'll show you. Watch. B squared plus 5b. I like to put the 104 on the other side. So it's going to be minus 104, and that equals 0. You okay with that? All right. Factoring is, you got to, it's kind of like backwards. It's kind of, well, there's no greatest common factor on this. But it's trinomial factoring. I don't know. You should have learned it in Algebra 1. Is it coming back to you? It's kind of like backwards FOIL method. A lot of teachers say that. You remember that? So it's like, watch. This times this. Listen, please. This times this has to equal b squared. So what times what equals b squared? B. Oops, almost put a square there. B here and a b here. Now look, this times this has to be negative 104. So that means one's going to be a plus and one's going to be a minus, right? Because if I multiply two things and it comes out to be negative, I got to have a negative and a positive. So now watch. These have to multiply to be negative 104, and they also have to add up to be a positive 5. Now 104 is not one of those numbers that pop into my head, and I realize what it is. So let's just try a couple of things. What was I thinking? Let's see. 2 goes into 104, doesn't it? How many times? 52 times, right? So if it ends at a 52, that means 4 goes into it, doesn't it? So 104 divided by 4 is 26. Is that right? Oh, 2 goes into 26, so that means 8 will go into 104. So watch, 104 divided by 8. 13. Now look at this. Is there any way to get a 5 out of these two numbers, 8 and 13? Yeah, there is. So if the 13 would go here and the 8 would go here, Everybody see that? So that multiplies to be negative 104 and it adds up to be positive 5. You'll be doing 1,000,000 of those in Algebra 2 next year. Maybe not 1,000,000, but you'll be doing a lot of this stuff. It'll be like second nature to you. Now watch what you do. This is something else that you're going to learn in Algebra 2 next year. You might have already learned it in Algebra 1. I don't know. Are you watching? It's a lot of talking. Heads turn. It's up here. All right, let's take a look at this. Just wait. You can wait 2 minutes, right? These two things are multiplied together to become 0. So you're going to learn something in Algebra 2 that says that either one of these could be 0. So I'm going to take b plus 13, set that equal to 0. And I'm going to take b minus 8, set... Yeah, you should have learned this in Algebra 1. Yep. Subtract 13 from both sides, so b is negative 13. Just add an 8 to both sides, and b is equal to 8. Now in Algebra 2, you would circle them both, you'd be done, and that would be your answer. But this is not quite Algebra 2. What are we trying to find? We're trying to find actual lengths, right? So remember what we had. We said b was equal to what? Negative 13 and positive 8, right? Do we use both of those? We can. That's right. You can't have a negative length, can you? B cannot be negative anything. So we just kind of get rid of it. And people flip out over that. Like, how can you just get rid of one of your answers? Well, it can't be a length. Agreed? It is a solution to our quadratic equation. No. It's a negative 13. It's not absolute value negative 13. It's actual 13, or negative 13. But this can't be a negative. So we forget that. We say the base is 8. So the base is 8. What's the height going to be then? B plus 5, which is 8 plus 5, which is 13. There's the base and there's the height. That's it. Okay. Let me give you some problems to do, okay? And then you guys can go win your game.
We already beat them before. You people? Yes.
What, by 2?
1.
Oh, Careful, the boys have a link.
They ruined my ankle at school.
That school ruined it?
Yes.
All right, there you go. There's your problems right there. 10 to 22. Okay? Enjoy
I
them.
did too, and they called it back.
They do that to Brian.
That was so